Okay, good evening, ladies and gentlemen. This is Chris Ewing, your instructor for Physics 111. We have a snow day tomorrow, which means we don't get a chance to meet before spring break. And what I'd like to do right now is because I posted a couple of take home labs, we are going to have to use the force sensor in each case. So what I thought I'd do is show you how to calibrate this thing. Now there's videos on there. Dr. Salen from University of Illinois has made some videos, and if you find them, great. But if you don't, here's the one that we can use for our class. So as you can see on my table, I have an IO lab sitting there and it has a hook in it. And I'm just going to go ahead and zoom. Let's try and zoom in a little bit so you can see what I'm doing. Okay, that's a little. So there we are. I'll just get rid of that. Okay, that's going to get edited. So here's my IO device, and as you can see, I have it on a level surface, and I have the dongle into the USB drive, and what I'm going to do is calibrate the device for the force sensor. Now that's going to be important. What you're going to need to do is you are going to need the IO device. You put the eye bolt in. Be careful how far you screw that in because you can damage the force sensor if you screw it in too hard, but just enough, about like this. Okay? And so now what I'm going to do is you'll also need a paper clip, and what you're going to do is turn that paper clip into a little bit of a hook, as you can see. Let me just get it over there. It's a little hook, and you're going to use that hook to pick up the IO lab by its force sensor, and that way you can actually you can measure the mass, but you can also calibrate the device. So let me go ahead and get into calibration. You click on the control panel and click calibration, and my panel is a little wide, so let me just do that. So I'll click on this calibration, and I want the force sensor. So now once you get there, you see that the force sensor is on, and this is not shown in the picture, but the USB drive is flashing. The IO Lab device is taking some data, and you can see that there's a force Y of 1.7, 1.8 thereabouts. So now that you let it sit for a few minutes, I'm going to click next, and it's asking me to pull it up. So I'm going to insert my hook just like this, and I'm going to pull it up for a few minutes, for a couple seconds, and then click next, and voila. This calibration process is really, really easy. So I'll click save, and I'm done. Now, another thing you're going to need to know is actually the mass of the IO Lab device. The advertised mass of it is 200 grams, about 0.2 kilograms. But let's check that. So I'm going to use my hook again. So here's my hook, and I'm going to use that to measure the IO Lab's mass. So what I need is the force sensor. So that's on, and you can see the graph. And what I'm going to do now is I am going to take data, and I'm going to have the force sensor going for a few seconds, and I'll take the average. So I'll just leave it here. So the hook is on. I'll click record. And now I'm going to pick up my sensor by the hook. And I'll just let it sit for a few minutes. And that should be good. Okay, so now I'll stop data collection, and you can see my graph on this window. So I'm going to say, hey, I want to know the mass of this thing. Well, I don't have the mass. I have the force. So if I scroll over, and I'm going to pick the flattest part of this curve, as you can see, this part right here where my vertical line is wiggling, I'm just going to take a sample of that from here to here, let's say. That's an easy one. And I'm going to say, okay, the average force, again, the mu value, is 1.96. And there isn't a whole lot of change in it. There's no slope or anything like that, so not a huge surprise. I'm going to call the force, the weight of the I/O device as 1.966 newtons. Let's call it 1.97 just for the cigar's sake. And now I'm going to bring up a calculator because what I want is I want to calculate out the mass. Now remember that the weight is equal to the mass times the gravity. So let me go ahead and do that. And I'm going to say, okay, here it is. My graph. And this is a nice thing because you can actually take this graph and copy it. So I'm just going to edit, copy. Hang on a second. Okay, so I have my screen with my force graph and everything like that. So I can put it up to the repository, which I think I will do. And this is for one of the new ones, so I'll just call it 2.0. So here is my weight of my object. And I'll call this weight. Weight of I/O 2.0. That's great. I have that. I'm going to take a screenshot of my force versus time graph. So there we go. And let me just go ahead and grab that. Save to clipboard. And now I'm going to paste it into my document. Like so. And there you have it. Perfect. So now, and you can do this with Word as well. So now I'm going to say, okay, my weight is 1.97 newtons. And so I'm going to do the weight equals mass times gravity. So I'm going to put in the mass, is equal to 1.96 g meters per second squared. And let me pull that up. Notice I'm including the units in this, and I think this is a good practice. And then I'll divide it by 9.81 meters per second squared. And carry that out. And here's what I get. 0.1997. It's pretty clear kilograms, but if you're accurate, 0.119 kilograms will do the job. Okay, so that's your weight of your device. Now you can actually do the experiment yourself and get a measurement of your own device. Make sure that you include the graph, share the graph with me, and also make sure in any lab documents that you have that you put the mass of your I/O lab into the report or the summary so that you have the record of that mass. And so when I read your reports or your colleagues read your reports, you can have evidence that you made the measurement.